Hello, right, this one, I'm going to try and repair the cable on this massive Hyde 9 high precision encoder, which has been squashed, as you guessed, when it was being taken out of the machine, or the machine it was in was being disassembled from about there. So there's very, very little cable left. I'm going to cut it a bit further down. I know it's got a dead short on. I put a new plug on it because the plug was also damaged. It's got a dead short on it across the power connections. So there's something in this, hopefully just in this section of cable, which is quite, no, it's about that, well, it's about a foot long, 3.5 long, that's being squashed. So hopefully it's just something in that that's been damaged, and the unit itself's okay, as they are unbelievably expensive. And I know the customer's going to be a lot happier if they can get this working rather than having to replace it. Now I'm going to try and cut along this. This jacket is, I don't know exactly what it is. It's some kind of rubber which is oil resistant. It could be some variant of polyurethane, or I don't know what else it could be. There's our other oil resistant rubbers. But most, oh, look at that. That has been absolutely shredded. Now, I don't think I'm cutting inside it. I didn't think I was. I think my cutters are going down the outside of the wrapping, but it's been squashed. Well, the cutters might have gone through the wrapping, I suppose, but there's a kind of synthetic paper, various things wrapped over the braid. Oh yeah, let me get a bit further down. I'll show you you can see where the wires are all damaged. I shall move that a little bit further in so I don't drop bits of fragmented wire everywhere, because it easily gets stuck on things and travels. That should be about back to where it's not flattened. But yeah, if you can see that the rubber was springing back and making it look like it wasn't as flat as it was, but you see the relative size between the flat version and the where it's been crushed in and where it's spread out. And you see it, let me just lift it up a bit so you can see better all the damage to it. Get that out of the way. You see it's like that blue one there, it's got a bit extruded sideways from it. That's the brown and white and green and white are the power input to it. Yeah, they're kind of crushed into the other wires there. Oh yeah, again. These have almost been pressure welded together. The plastic's just flowed everywhere. And you can see bare wire there, and that grey one, the wiring's showing. That's not good. Right, I need to go a bit further, so I've got definitely undamaged cable. Not sure quite how bad it was. Oh, this is totally different to strip back now. That's what it's more like it's supposed to be. You can see it's just going down the wrapping, and you can barely see the braid. Whereas that braid is totally destroyed. It's just been torn apart by the cable expanding inside it. What a mess. So where's the last of the crushing? So I need to find the last point where there's obvious damage. about there. There's a lot of wire squashed together just there, but just beyond that it's not bad. So I'm going to cut it just beyond, because that might be okay to sort of strip if the insulation's damaged. And I need a couple of inches to try and make the splice, because I want to offset the joints a little bit so it doesn't get too fat. I've got some adhesive lined heat shrink to go over the joint. I'll try that, see if that's long enough. Just take the rest of the jacket off and see what happens. Right. Yeah, that's just completely shredded. Never seen anything that bad. Okay, so we can get this back without getting hopefully any splinters. Once copper braid's been chopped up like that, it's very, very easy. It can have little tags hanging on the end of it. Now that's what it's supposed to look like there. It's not damaged. You see the difference between that and the braid that's in there? It's looks like it's been pulped, and then that's the undamaged part. And when you saw that there was just a clean cut. Look at the difference in the braids. You can see where it's started to be destroyed by being squashed just about there. Oh, by the way, these encoders have got their own bearing and a floating coupling of some sort inside. So me moving this about is not affecting the actual glass disc and everything. That's deliberately decoupled from the hub. So slight misalignment on the machine doesn't cause it problems or accuracy errors. So that is supposed to do with that, and it does not affect the precision of the mechanism at all. Right, so let me trim the braid back a bit more to tidy it up. So that's all very messy. We got something like clean end on that, and then it should fold back over the outer of the cable, so I can keep it out of the way without shortening it too much. Bit of luck. Especially just turn it inside out. And then it'll go back over again once I've done the main splicing. Right, get rid of all the extra bits. Now that's the jacket. Normally, if you're careful when you're cutting down the outer, then that keeps you from, oh sorry, there's another layer of that around the outside I've already removed, and that separates both sides of the braid. The outer version of that stops you cutting the braid. And then there's a tensile core on most machine tool cables where they're intended to be flexing a lot. There's a tensile core to stop the load being applied to the copper when it's pulled. You sometimes have an absolutely massive one that's a third of the diameter of the cable or half the diameter of the cable, or lots of interleaved ones even to make up for different size strands. Now this has got different size strands or different size wires. There's 4 big ones for power and 2 thin ones. What is it? Oh, there it is. Yeah. So they're the power supply and power sense, and then there's 4 other pairs, so 12 in total. Those are the A and B signals, those 2, and then that's the reference signal. And this is, in this particular type, I believe this is completely unused. In some the purple wire is a fault signal, and the yellow wire is generally unused in those as well. You can see there's bits of copper everywhere. It's bits of braid. This is covered in them. Right, so now I need to do something similar, but not so critically. At the other side, I need to just chop out this damaged section completely. I'm not going to try stripping it back. I'm just going to cut it clear, and then I can look at setting up on deciding how to splice it. I'm just curious as well how badly these have got mashed. You see, it's very, very flattened on that one. How much force has been applied? It's probably, like I say, I think it's something like a machine jack or a metal slab used to put a jack on it. And they're definitely very, very crushed. And one thing I can try, just to double check, is to see if the short across the power's gone. That's on pins, I think it's 10 and 12 are one set, 2 and 9 are the others. So if no combination of those has a short, there's a bit of capacitance or something there, but no. No, there's no combination of those has a short, so the short's definitely been cut out of that side of it. It wasn't in the other half of the cable. The big question is it clear in this one as well? I need to really strip this down first and get ready to splice it. I don't want to just start stripping things back at random. So cut this. It's quite a bit of force because this stuff is very resilient. That one through, which is quite usual, but it's weaken it down enough so it'll split. It's a lot tougher than PVC on normal cable. A normal PVC cable, once you've got a bit of a scratch around it and start it splitting through anywhere, the brake just runs around it. This hardly runs at all. No, let's just snap the last bit. Right. This remains of the outer. It's like a synthetic. I don't know what it is. It's almost like non-woven fabric cleaning cloths. Same on here. Just push that back over the outside so it's out of the way. And get rid of all the excess stuff around the wires and the strainer cord in the middle. There's another version of this cable for the digital output ones, or the kind of hybrid digital ones. There's roughly 3 categories of encoder outputs. There's the Quadrature ABZ type, which this is, but this is a sine wave. Then there's ABZ digital, which is logic levels or open collector output rather than analog. And then there's also not exactly intelligent ones, but ones with a microprocessor built in, and the output is, well, one of the types is called SSI. It's something like SPI in a microprocessor. It's got data and clock lines, but there's everything's balanced line to avoid noise over distance. So there's 2 more pairs of data, in addition usually to the ABZ analog or TTL ones, the Quadrature. There's actually another type as well, thinking about it, used in motors. So I'm just checking I've not lost anything. That's the more. Right, they're used in servo motors. I mean, they often have an encoder included, which may be a Quadrature one, or it may be, for a basic brushless DC one, just a 3 output Hall effect type. That's just 3 different logic signals. Each are on for 50% of the rotation, but offset 1/3, 2/3 around it to give equal signals for the 3 phases. All right, just coffee top up. And they can have both in, so they can end up with a plug with more pins on it and a lot more wires. Yeah, but one of the serial bands patch a damaged cable on a machine a while ago. The cable chain had broken and the cable had got crushed. That's the first time I actually did one of those. And that basically got another screen, another set of insulation, another screen, and 2 more screen twisted pairs down the centre, and then this similar setup around the outside of it. So it's not much bigger, but a lot more complex to join up. Anyway, I need to stop talking about it and do it. I'll work out where to do the joints on this. I don't want to do any nearer than about 1/2 inch to the end, but I want to try and stagger them to some extent through the length of the joint, the length of the splice. So I haven't got a load of heat shrink tubes all in one area, making it very, very fat in one area and then thin in another area. I want to try and distribute them a bit. So I'm going to do them in pairs. Do the 2 input power wires at that end. So I'm going to do them about out there. Then those 2, which I think are the A pair, or the B pair, sorry, I think they're B. Look about 1/4 inch 6mm intervals. So there's a bit of overlap, but they'll get done within the area. And I think that's the A pair. I know it's one or the other. And Z. Then those all, on principle, I'm going to join them even if they're not used. And then finally the other power pair, the sensing pair. Right, so then I need to match that working the other way, so I have more or less equal wire lengths. So I'm going to put that about there, then work back. So if that one's there, yellow and purple might not be perfect, but as long as they'll wrap in. If anything, I want to leave the thin wires a bit longer than the thick ones, so they're not getting tension on them. So yellow and purple about there. Use that blue and white as the reference length. And black about there. Brown and green. About there. Pink and slate. Roughly there. Might be a bit long, but better than being short. Both cut. And then the other pair of power wires, try and keep them fairly accurate at about that. Okay, so now it's strip them all back and start. Well, I've got to find some sleeving. I've got some big stuff, I've got to dig out some small stuff yet. This is also very resilient insulation on these things. It can be hard to strip. It can just stretch out and flatten out rather than stripping off. Ha! Oh, that's pulling out the cable, I don't want to do that. I think that cable's not been pulled too badly there. If that was trapped as pulled, it could have damaged all the connections inside it, which is not good. That would be a major. That would be a disassembly job then, which is not something I'd do by choice. But if the thing's otherwise dead, then I've got no choice. It's not doing any harm to try it. Extremely fine wire on these. The finer it is, the more flex it can stand without fatigue. Oh, another slight oddity or novelty on this compared to the commoner types of encoders is its distance coded referencing. Whereas normal simple rotary encoders, if they have a reference at all, it's a single point, like on the little one I demonstrated on the previous video. Whereas this one, to say, and a lot of the newer linear ones for the last decade or two, newer, they've got distance coding. So rather than having to run the machine right to one end of its travel or to some fixed point in its travel every time to re-reference it if the power's been off, you only have to move it a few inches or 100 mil or something. And it's a very simple but ingenious system. Rather than having just one reference mark that says that's its zero position, the reference marks are spaced all the way along or all the way around the encoder, but at different intervals. So say the reference mark, the basic value of reference is, the first one is, there's the one at an extreme end, and then the next one, say 50 mil away from it, or 50 degrees away from it. The one after that would be, say, for the sake of argument, call it 49.9 millimeters further on, then the next one 49.8 millimeters further on. So the machine's only ever got to travel from one reference to the next, which worst case is about double the distance. And by comparing how far it's moved to how far between reference pulses, it can know which number reference index along the scale or around the rotation it's at, which makes starting with a machine a lot simpler, especially if it's got some piece of work on the machine, a project on the machine, a job that means it's difficult to move it full space, or it would mean taking tooling out and doing a lot more work to re-reference it. You've only got to move it a small amount, and it knows exactly where it is to the whatever the precision of the measuring system is. It could be 1 micron, 5 micron, something like that. It's a good system. And there are also absolute encoders, either purely optomechanical or electronic, that store, give the absolute position, usually on those by the serial data interface, or some of the early ones by a massive parallel interface. And they either read directly through multiple geared discs that to count the turns as well as the position within a turn, or by using a conventional encoder with a microprocessor that's got its own power backup and permanently remembers the position, or as long as the power is available. And then the machine doesn't need to move at all to know where it is. It doesn't matter how long the power's been off, as long as the backup battery or the system's working correctly. It just knows where it is as soon as it reads data from the encoder. I mean, FANUC machines often have that, or FANUC machines with FANUC controls. There's a battery on the front, or depending on the age of the machine, it's either in a little box mounted on the machine control kind of cabinet, or the electronics cabinet, a battery box set in the side of it, or there's a little battery that clips onto the front of a drive module, or either shared between modules, or one in each. And basically it's like a Siemens backup battery. It's just memory backup for the drive or the motor. So the position is stored and you don't have to re-reference it every time. Now, some of those do need re-referencing, recalibrating if the battery goes flat or the battery's disconnected whilst the machine's not powered up. Now, there are other types that just know the position inherently, if you like, and work without backup. Right, these are each going to have a kind of parallel side-by-side splice joint, which isn't mechanically perfect, but due to the size of the cable, trying to keep the thickness down of the splice, I've got no other option really. Trying to twist them or double them back on each other or whatever would make the overall thing just too big. So I'm probably going to try and reinforce the joint over the outside, but basically it should never be pulled or messed with anyway, so it's down to just the installers being very, very careful with it when it's put into the machine and make sure the cable's properly supported without ever being pulled on or squashed again. Right, almost all tinned. Yeah, actually stripped quite nicely, man. They're good cutters, these. Flush cuts, which make stripping wire a lot easier because there's no chamfer on that side. So the pulling, once you nip into the insulation, they're pulling square against it rather than a normal double angled cutter where there's a kind of slope for the insulation to slide past. Nipex, that was, there's a model number on there. But found a place on eBay selling them at quite a reasonable price. Can't remember where it was offhand. Right, now, one check I should have done as soon as I meant to do, as soon as I stripped those, or prepared those wires at that side, is make sure the thing's not shorted. Now that damaged wire's gone. And the main power, make the meters working, Main power is brown and green. That's more like it. It's not shorted anymore. And those should go to that one. That should be a sense. That's directly connected. That's a sense wire from the brown and green. And that the white is a sense wire from the white and green. So they should be low resistance. This meter, these cheap leads, they read about 0.4 of an ohm when they short circuit. So yes, that looks now like the short was in the cable, and the encoder has a chance of being okay. Oh, there's that one that pulled. I wonder what that's like. And there wasn't enough force on it to have pulled it out if it was actually anchored. It just seemed to slide. Maybe there's just some spare wire inside the other end where it's made up, and it's pulled on that. Well, it should have an op-amp driver on the end, so there should be a reading. Yeah. Yeah. And it should be similar to the other pairs, A and B. Get a stable reading on it. Yeah, I think it's okay. Right, so next one is some suitable heatshrink. Okay, continuing the cable repair on this encoder. I've now got the heatshrink sorted out. A number of little pieces cut ready for the individual wires, and I've put a couple of bits of very large high shrink, it's 4:1 shrink, adhesive lined on the cable that I can thread over the joint after it's done. So it's better to do that before you do the joint, and found you need to undo it to put it back on again. Which, I've not done for a long time, but I have done in the past. Oh well. Right. Okay, so the soldering iron's all warmed up and cleaned up. 350 degrees. So can I do the longest ones first? So that brown, green, white, green. Now with a bit of luck and get the orientation right, these should all go straight through. Might need a bit of a twist on it, but hopefully not too bad. Get those above as they are on the other end. Then it's basically a matter of holding the two together and clean the iron a bit. That is in view, isn't it? Yeah. Try and get the angles just right. I don't actually, there's not enough grip to pull. That looks to be flowed okay. I don't actually pull too hard on the short ends of these because I don't know where they go to in the encoder. I mean, hopefully it's just a connector somewhere in there, but I don't know for sure. I don't want to risk damaging the thing by pulling the wires. As these are all already been tinned, just a bit of fresh solder and a bit of heat should give quite a decent joint. If it doesn't, then I'll redo it, re-tin them. Now that's got a stray strand on it, which you shouldn't have, so it can't, one side of it can't have been fully tinned. I think it was that one. Oh, by the way, I'm now trying a different mic again. This is a little lapel mic to try and reduce the ambient noise from the computer at the side of. Better. Oh, don't pull. Okay, those two will do. So the next, to the two longest to that side there, that yellow and purple. So I'll do those. See in there, keep springing them out in the way. the end of the solder will just dangle over the bench so I can touch it with the iron just before I go to do the joint to make sure it's fresh solder. That looks good. I'm going to stick that up there. Yeah, occasionally if this snags in the stand with this style of slide-on spring-loaded tip, you can start pulling the tip away from the iron, so occasionally just kind of stick it down and make sure it's pressed fully on, because if it's not fully on, you don't get as good heat transfer as you should. I just had it happen occasionally in the past. Oh, that was not tinned. I must have got distracted and started thinking about heat shrink before I finished tinning them all. I was kind of thinking ahead and lost track of what I was doing. That's the purple one. Not too bothered if the joint's a little bit lumpy, as long as it's flowed well. The heat shrink will cover it. I can always trim it down. So we'll do that on that one. There's a little pip on the side of the joint, just a bit where the soldering line is pulled away. There. Okay, that's 4 done, 8 to go. Right, which next? The slate and pink, I think. That's hiding under there. It's a few days actually since I started this, got involved in other stuff. So I can't remember exactly what I said in the previous video because I've not really looked at it. But yeah, this calling grey slate is a kind of ingrained habit from old cable colour abbreviations. There's 2-letter abbreviations for most colours, but some of them have got to use slightly alternate names or lettering. Because if you call that grey, GR, then it's the same as green. So you call it slate, as in slate grey, and it's SL, which is totally unique. It's a convenient shorthand when you're writing down lists of colours. If you can do everything with 2 letters rather than having to write out long names. Come on, flow. It's almost hiding behind the grey wire and it doesn't want to flow. And that's starting to transfer some heat now. It's been hot so long. That'll do. This iron does oxidise, or the solder on the iron rather, does oxidise quite quickly at this temperature, so I do keep checking it regularly. I need that where I can get to it. Sit it on there, maybe better. Right. Nope. Ow. Oh, that's, yeah, that got hot. Ow. Right. Okay, halfway. I might have to start turning this over or turn it around or something to get the wires in the right place. No, it is stable like that. I didn't want it to fall over and jar and anything, risk breaking anything, but it does appear to be okay standing like that. Right, so now blue and white, which are the power sense wires for the voltage regulator if it uses it in the control side. that over as well, try and get them a bit nearer the top. That doesn't look good. Oh, I think let's retin that again. Right. So we get those two to go together. That's got a little bit of a lump on it, but it's a good solid joint, so I'm not too bothered. This is tricky enough doing it on the bench, but sometimes I have to do it actually on the machine with everything still connected, and that makes this look easy. Right, brown and green are the next pair to do, which are there. That's one of them to the wrong side of that white wire, I think is that one, just for convenience. Just putting the heat shrink on whichever end's longest. That red and black's going to be fun because they're almost the same length, and if you get too close to the heat shrink, it starts heat shrinking from the heat being transferred along the wire, and I keep headbutting the phone so it's recording. I'm trying to look over the top of this thing. If you see any sudden movements or weird noises, so the noise is any sound should be coming from the lapel mic, so it's me moving about. If anything, it's clipped on my collar. Now that one's a bit close. I don't want to heat the heat shrink up when I'm cooking the joint. But luckily they're very thin wires, they don't take much heat. If they're properly tinned. Yeah, that's good. No, not happy with that. Again, it doesn't look like that wire. Tinned. No, this is, I think it's 1998 it's dated. So it's over 25 years old, which may mean there's a little bit of oxidisation on the wire, which might didn't tin as quickly as I would expect normally. I mean, it appears to be done on the surface, but when you look round it, the solder's not quite flowed through all the way on some strands. Not the first time anyway. It does with it just needs a bit more time for the flux to work and get rid of any oxides. I think that's the longer one on that, so it's going on that. Then I've got to go through and shrink them all, without shrinking any in the wrong positions, which is again, because it's also tight, that's going to be interesting. I don't want to touch anything else. Now that one's going to be awkward. Just trying to slide the heat shrink off when I'm pulling it. Right, different approach. Figure out where I can grip the thing, move it into place, and where the end of the solder's gone. happy with that. Looking closely, some of these just don't look quite right. A bit more time, a bit more flux tinning them, just to be sure. That one looks good. Okay, that's that one, and last one. Now, once I've got the initial joint done, before I put the outer sleeving on, I'm going to test this little encoder tester I lashed up from parts, which should display the output. Yep, that's it. So now I need to try and position all the insulation somewhere in the right place. What I normally do to make sure it's centered is move it to one end, mark it with your finger, move it to the opposite end so it's just off the joint, and then move it back halfway. But for most of these, there's not enough room to do that, so it's just a matter of well, that's another reason I made the sleeves quite long, so the positioning does not have to be too accurate. And also done the two in each pair the same length, so if I get one I got the other automatically, just by putting it parallel. So brown and green are there. Need something to manipulate those a bit better. Very useful thing is artery forceps, or hemostats as they may be called in some places. Let me get that bit back over there. And move these about with a bit less disturbance to the others, with the fine tips on these, rather than trying to stick my fingers into bundles. Get that wire straight there. That green and white. The green and white somewhere in there with the sleeve outfit. Right. And that wants to go about there, slate, and then pink, wherever pink's gone, that needs, that's the same. Not sure if that's it. Yeah, I don't actually remember setting those specifically, but that's about right there. I think that's something like. So, just need to grab the little torch to cook them on. I got this out, but not brought it through. It's just a little butane torch. This particular one is a very nice one. Got two other things. The other's a slightly different style, and it's the flame control's terrible. Every movement messes up the flame level, whereas this thing, you can, more than a few seconds after it's been filled, when you first fill it, it can be a bit unstable, but after a few seconds, and then from then on until it's empty, the flame stability is superb. Not a clue what make it is. It's only a cheap thing, but no date on there. 2004 I got it apparently. And this is keep moving. You want to distribute the heat so nothing gets too hot but everything gets warm. Just turn it up a little bit. And keep moving from different sides, different positions. You don't want to scorch anything. If you're doing it, all the sleeving to shrink down. That's starting to go there. And concentrate on individual ones once they're mostly in place. That's one or two there need to be a different angle for, I think. That's why they mean shielded by others. Make sure that's still in view. Yeah, that's gripping now. Right, okay. Encoder tester. 5-volt power supply. The gadget itself, and somewhere in here. That's the 9-pin. I need a 12-pin high 9 style adapter. So this, the idea of this is it's a kind of tap in. The plug and socket are connected straight through, so it can still be connected to a machine, and then that plugs into my tester, and can get around. Well, it can monitor the signals. Because it's very low power, it can actually run from the 5-volt supply on the machine if it's connected to a machine, or unplug in a 5-volt adapter at the side of it. So let's see what happens. So that needs to connect to that. The solder out of the way. Now polarised plugs, of course. So that goes that way. That's connected. Now I need power, and hope it works. So I turn it. So you can get both visible, so you can see me turning it. So yeah, that's it. Sine and cosine signals. So it is now working. I can look at the reference on this, but because I don't know where it is, and it's literally one single pulse somewhere on the whole revolution of the thing, I don't be able to find it whilst it's not being on the machine, and it's turn it faster. Obviously the waveform's quicker, but I don't know if I'll be able to find the reference. I don't know which one it is. Oh. Yeah, I think that's looking at A and Z rather than A and B now. Oh, there, got it. That's his reference pulse. Yeah, so yes, the reference is working as well. Excellent. Right, I'm happy about that. Right, I'm going to finish repairing the cable now. And check it again. Yeah, these are the general class is an M23 connector. I think that's supposed to have an O-ring in that groove. Actually, it's gone. And when they're properly set up, they are waterproof once they're fully connected and locked together. You know, they're IP67 or IP68 rated. So the idea is they don't get anything in contamination wise, even if the cable ends up being under an oil leak or dropped into an oil tank or anything like that. The cable itself's oil resistant. No, don't then burn it on the soldering iron. Right. Okay, so I now need to tape this up better to hold everything together. It's going to be a little bit lumpy. And I need some self-amalgamating tape to do that, which hopefully I've got somewhere. Okay, so another couple of days later, by the time I've got back to this, the tape was stored in the garage, and due to the temperature it was basically like a solid brick. It was not flexible, so it's had to wait a while to warm up. That's now more like it should be. So these are all in place, and I'm going to put a layer or 2 or 3, depending how much it needs, of this over it. This is self-amalgamating tape, which is why it's got a backing strip on it. It sticks to itself. It's not actually adhesive, it's more like pre-set contact adhesive, but it's a very, very flexible, stretchy rubber type material once you get the backing off it, which can be fun. So it's very, very soft and flexible, and it sticks to itself, so I'm not going to demonstrate that until it's on, but basically you just wrap it and stretch it at the same time to make sure it's under tension, so there's compression inside the wrap. And within a fairly short time, it'll stick in seconds to start with, lightly. It's picking a bit of stuff up, although it's not strictly adhesive. I think it's just static or something. It's just picking some light junk up because there's bits on that paper underneath. That's got it, mostly. And I want to make this fairly even up to the ends, so what I'm doing now is really stretch it like mad and kind of twist it in to fill the little notch. I'm saying, oh, this is now semi-stuck, but not really solid. As soon as it contacts, you can peel it off again within the first few seconds, but over a few hours it will completely merge into one single chunk of rubber. And it is extremely good for waterproofing, sealing, gap filling, all sorts of things. I'll do at that end. I had some on a aerial connector outdoors for about 20 years, and when I eventually took it apart, when it used out sorry, I've got a dry throat. When it used outdoors, you got to wrap it with a normal insulating tape or something to protect it from sunlight, because it is affected by sunlight and ozone. But after 20 years, the outer tape was looking a bit shabby, but the self-amalgamating wrap inside it was basically, it looked like it had been moulded around the connectors. You know, that was being used to waterproof. It was just a shell of rubber. I had to slit it off with a knife, and after slitting it out in half, it had got a perfect imprint of everything inside it, and it was just, you couldn't see any layers or anything. It was just one solid block, and that's a bit thick and messy, but you can't do much about that at the moment because of all the heat shrink inside it. Now I'm going to try and see if I can work this braid back over it. I don't know how well it'll go, but that's the next idea. Yeah, it's good stuff for certain applications. It's not universal, but we need something that'll conform to things. I also used a lot on big crimp terminals to insulate the end of the wire and the crimpable part of the sleeve on, you know, big uninsulated crimp lugs. It's good for that, and it doesn't come loose. That's the big advantage. Once it's on, it's there, and it never comes loose because it's as good as a kind of shrink sleeve or anything afterwards. Now that's not going to go back, unfortunately. I'm going to have to shred it or separate it and then put it back a bit at a time to join up. I just want something like approximate coverage and a few strands end-to-end soldered just to give it screen continuity. Don't have to be perfect, but I definitely want some screening over it, and it's probably more especially screen continuity. But, trying to get it separated out can be a bit tricky. Interesting with it, anything like this, any kind of stuff like this where it can tangle, if you pull a single strand or cluster, it'll come out a lot easier than if you try and pull more than one at a time. And this is in groups of about 5 or 6 wires, something like that, in each kind of section of the mesh, of the braid. If you pull one, it'll almost always come out. If you pull two, because they're interleaved opposite ways around the strands in between, they grip and don't go anywhere, or just break. It's got a bit tangled where I was messing it at the far end as well, which doesn't help. It's always easy to do when it's not being twisted up. There it goes. It's a bit tedious, but it's part of doing a decent job that's going to last. Not far off, just a few more. That's mostly now just a spiral around that. Right, so that's long enough to go fairly well down it. Next thing is to try and get the other end done at the same, and then interleave the two and do a few twists and spot joints to give it some level of continuity. As long as they're all held down and it's got several joints in it, the screening will be okay. And it should all hopefully then work well for whoever knows how long, a good time, a good length of time. Right, so I want that one going that way. I'm going to put a temporary wrap of normal tape around that, just to hold it. And the same from the other side, and try and merge the two a bit, then just dots of solder to give continuity. And hopefully that will work something like. That's that side. Some bits joined together. Keep the joints fairly flat as well, so don't take too much space around too much bulk. I don't want to use all the wires either, because I want to leave some to interleave into the rest of it. There's still got some traces of braid left there. Again there. Right, that's the one I want, I think. just kind of lay them all over it. Solder those little clusters I've done. And basically then I just need to try and get the rest of the wire something like in place. And hopefully figure out how to hold it down so it's going to stay in place whilst the heat shrink goes over it. If I just twist around a bit, that's one that should be going the other way. There we go, that should do. It's not. Get that off without making a mess of what I've just wrapped. Like that. And that should be ready for the first layer heat shrink to go over it. That's one there, it's going the wrong way. Try and wrap it in again, all better. Right, so next, first piece of heat shrink, try and get over without disturbing anything. Without catching any of the bits I've just tried to lay down. I'll leave a bit of clear space on it after the end of that, but not a lot. And that needs shrinking in place. Let's just turn this on and off. Hang on, this is adhesive lined heat shrink. It's a very high ratio one. I think it's 4:1 or 5:1 or something, hopefully. Somewhere in that region. So it will go down a long way. I want to try and get it evenly. That has the advantage of making the adhesive layer a lot thicker once it's all been compressed down by the shrinking. Also try and shrink it all the way around somewhat evenly. See where it's not shrinking, you can see the little ripples in it, that the one there. Obviously the ends, because the end, I've been careful with the ends because the ends burn easiest because they've got open space. And you can get both sides a lot easier. Put that somewhere where it's not going to set anything on fire for a minute, and turn that on edge, and have another go at it. The idea is to try and get everything down evenly without scorching anything. That's the underside done. Back that way. Still bits at this end that aren't quite down. Also not set fire to me. Paper I'm using to protect the bench. I'll protect this from the bench, whichever. Catch the bits. That's about it for that layer. can see the adhesive starting to ooze at the ends of this. So it should have a fairly good seal to the cable. Now I want to put another one on with a, I don't want to go right up to that end. I mean, it doesn't have, it's not going to be flexing continuously. Once it's in place, they should stay unmoved until the machine is dismantled for some reason. So it doesn't have to have a lot of flexing range, but it does want to have some. I don't want to join it straight up to the crimp on that strain leaf, whatever it is you want to call it there. It's not exactly a strain leaf, it's just an attachment. I also want to let that cool enough so when I put the next piece over, I might want to trim this down a bit, it's a bit long. I mean, how long is that? That's there. Yeah, doesn't need to be that long, so I'll just trim it a bit of that. Go to about there. Just take that bit off completely. And then just tidy that up a bit. That's reasonably neat to that. Okay, so, oh yeah. I mentioned a normal way of setting heatshrink central on a joint. If you look at that end, get that end level, just mark it there with my finger, go to the other end until I can see that. So that's there. So that's the total overlap, so I want to be halfway back on that, about there. That should give me an equal overlap at both ends, or fairly close to it. So again, shrinking. It's a bit on the side. To work something like from the middle outwards to minimise the trapped air bubbles in it, because it's adhesive, it won't ooze air out much. But it will ooze the adhesive out. So if anything, I want to work any excess adhesive towards the end where it needs the sealing more. Just want to do it slow enough so the cable itself's warming up through the heat shrink. So there's a better chance of bonding, though I don't know what will bond to this stuff. Looks like just a very slight scorch there. You just see it start to bubble, which if you get too bad it just catches fire, which is not good. And that was just a bare trace of a scorch. So hopefully it's not doing any harm. Check that one from underneath as well. So you can just see it's just got a slight change in colour there, a little bit too hot. And that's that end, so I'll try and get this one. It's a bit lumpy there, I don't know why. Oops, another scorch. Again, not bad. I'll do. This. Yeah, That's oozing glue, so that one's already oozed glue, so they should be really good seals. Just get that, you can see how clearly. But the glue lining has melted thoroughly and started to ooze at the ends a bit, which shows it's fully melted and should have good adhesion sealing to the cable underneath. Okay, next thing is test again. So we'll get the encoder tester back. I don't want to bend that too much. I'm going to keep that reasonably straight whilst it's cooling. The other bits in here, I made adapters for several different types of encoder used on different machines and different styles of connections, for different Heidenhain and Siemens ones mainly. So that's why it's not just a single connection on this gadget, because it can work with multiple signal types and pinouts through the adapters. I mean, the earliest ones, which they're still very, very common because they're so simple and reliable. The sine wave system, they're literally, as well as the light source and stuff I showed in the rotary encoder, and the grating to give the lines over a large area as it moved. The actual sensors are just parallel opposed photovoltaic cells, so depending which one it is, the voltage changes amplitude and polarity. So there's no active electronics whatsoever. There's a light source and 3 pairs of back-to-back photocells. So there's not a lot to go wrong electrically, but the signal output is very, very low. It's 11 microamps maximum. So you get 1 volt, approximately 1 volt over about 100k load. But it does be, oh dear. Oh, hang on, that's it. I forgot to change it to show A and Z, not A and B. That's more like it. So that is, oh sorry, can't even see it on the video. That's showing the sine cosine plot as X and Y. Go back onto that screen, then that's the actual sine cosine waveforms. So it's difficult to get a suitable speed to see a nice low count because this thing is 18,000 lines. There we go. That gives you a nice view of the 2-channel waveforms. See that each one crosses 0 about the same time as the others at one of the peaks. Go back to that other screen again. And that shows that the two are pretty accurately 90 degrees apart. Oops. Got a connection. Yeah. Power supply connector's a bit loose or something. Oh. Is that me moving the... Oh. There's something not right there. I'm not happy about. I don't know what. Power supply possibly not strong enough for this big encoder. And my meter just died. I think power supply, I don't know.
It's nothing to do with flexing that, at least. I say that had me worried for a second. It's something. It's something. It's this. It's this power connector. I think. Yeah, the power connector's a bit dodgy. Right. Panic over. Back to what I was doing. Say normally if this is connected in line with the cable on the machine, then it doesn't use the external power connection. But back to what I was saying, that's showing, because that's a pretty accurate circle, so it's showing that the two signals are well matched, 90 degrees apart and similar amplitude. If there were a different phasing other than 90 degrees, then it'd be an ellipse angled one way or the other, basically stretched. It'd be gradually changing from a circle to a straight line as the angle difference went down from 90 to 0. But that's a nice circle, so I'm happy with that everything's working in the encoder itself, and the only damage was to the cable. Okay, anyway, that's it. Thanks for watching. Please click the thumbs up like button and subscribe if you like seeing stuff like this. And any questions, please put them in the comments.